So let's go ahead and put our confidence interval method to work here. In this example, we've got a clinical trial of induced osteoarthritis biologic. Participants are divided into experimental and control group or placebo group, both of size 50. One of the trial endpoints is lower use of rescue medication. So if the pain gets too bad, they take Advil or Tylenol. So they keep track of how many people do that. So in the experimental group, 15 subjects needed rescue meds, while it was 28 in the placebo group. We're going to construct a 99% confidence interval for difference in proportions and interpret our result. So test requirements, independent random samples. So while this is a clinical trial, if they're using good trial design, they should have done independent random samples. So that should be satisfied. 50 should be less than 5% of the population, certainly. I got millions of people that have arthritis. And then we need to check our successes and failures here, are at least 15 in both populations. So P1 hat, success out of sample size. So success means they used rescue meds. So there were 15 here, 15 subjects that needed rescue meds out of 50. Which is 0.30. And then in the placebo group, there were 28 here out of 50, which is 0.56. So N1 P1 hat is going to be 50 times 0.3, which is 15. N1 1 minus P1 hat. So 1 minus 0.3 is 0.7. So this will be 50 times 0.70, which is 35. Both of these are greater than or equal 15. And then the same thing for the second population. So N2 P2 hat is going to be 50 times the 0.56. And that's 28, which is greater than or equal 15. And then N2 1 minus P2 hat will be 50 times 1 minus 0.56, it'd be 0.44. And that is 22, which is greater than or equal 15. So that checks. So all three requirements are satisfied. So then this is the formula for our interval. We're using the approximation because we don't know P1, P2, but we do know P1 hat, P2 hat. So X, we don't want X1 bar in there. We want P1 hat minus P2 hat. Typo. So first proportion 0.3, second one 0.56. So this will be 0.3 minus 0.56 plus or minus Z alpha over 2. So this was 99% confidence. So we're using the Z distribution so we can use our common confidence coefficient table. So these are our confidence coefficients from chapter 7. So for 99% there, you can see we need 2.575. So 2.575. And then times our square root. We're going to run out of room for that guy here. Let's go ahead and make some more room for ourselves. I'm not having good luck here. There we go. Let's bring this down to the next line. Okay, so P1 hat, 1 minus P1 hat. So that's going to be 0.3 times 0.7. Divide by N1 is 50. Plus, and then P2 hat, 0.56. And then 1 minus that is going to be 0.44. And that's also over 50. And all underneath the square root. So this is negative let's see, that's negative 0.26 plus or minus. And then if you enter this quantity in the calculator to 2 decimal places, you get 0.25. So negative 0.26 minus 0.25 is negative 0.51. And then negative 0.26 plus 0.25 is negative 0.01. And so we are 90% confident that the difference of proportions is in that interval. So we're 90% confident that the difference, population difference in proportions is between negative 0.51 and negative 0.01. So notice that this interval does not contain 0. That means that we're 90% confident that the difference in proportions is negative. So that would mean that the first proportion is smaller than the second proportion. And that would mean that there's less rescue medication in the treatment group than there is in the placebo group.